Arithmetic sequence. Definition of an arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. The difference between the two consecutive terms is called the common difference of the sequence. An arithmetic sequence is a linear function whose domain is a set of positive integers. Example 1, we're going to write the first 5 terms of the arithmetic sequence with the given first term a1 as 180 and d as negative 10. So here we have the first term is 180. So a2 is equal to 180 plus our common difference, which is negative 10. So a2 is 170. A3 is equal to 170 plus our common difference of negative 10, which is 160. A4 is equal to 160 plus our common difference of negative 10, which is 150. And a sub 5 is equal to 150 plus our common difference of negative 10 to give me 140. So note here our sequence is 180, 170, 160, 150, 140, so on. The general term of an arithmetic sequence with the first term a1 and the common difference is d is a sub n equals a1 plus parentheses n minus 1 times d. And we'll clean it up to write the proper a sub n without any parentheses. Use the formula for the general term or the nth term of an arithmetic sequence to find the 90th term. So I don't want to sit there and add negative 5 each time to the preceding term until we get to a sub 90. So the formula says here that we can apply a sub n equals a1 plus n minus 1 times d. And note here d is negative 5 and a1 is 7. So applying that, we have a sub n equals a1 is 7 plus n minus 1, and our d is negative 5. So cleaning the nth term formula up first, a sub n equals 7, and note distribute negative 5 times n is negative 5n, and negative 5 times negative 1 is positive 5, and simplifying that, a sub n equals negative 5n plus 12. So our nth term here is equal to negative 5n plus 12. So to find the 90th term, all we're doing is plugging in 90 for the n. So negative 5 times 90 plus 12. So a sub 90 equals negative 438. Write the formula for the general term, the nth term of the arithmetic sequence below. So we have 4, comma negative 1, comma negative 6, comma negative 11. So we know a1 here is 4. And to find our d, we're going to say a2 minus a1, which is negative 5. And we can double check. We can say a3 minus a2, which is still negative 5. So we know d is negative 5. And my formula is a sub n equals a1 plus parentheses n minus 1 times d. A sub n is equal to 4 plus n minus 1 times d is negative 5. So a sub n equals 4 plus distributing, negative 5 times n is negative 5n, and negative 5 times negative 1 is positive 5. And simplifying that, a sub n is equal to 4 plus 5 is 9, and so it's negative 5n plus 9. And a sub 15 is plugging in 15 for the n value. Negative 5 times 15 plus 9 gives me negative 66. The sum of the first n terms of an arithmetic sequence. If we have a1 and a common difference of d, the sum of the first n term is given by n divided by 2, parentheses, the first term plus the nth term, or S sub n equals n divided by 2, parentheses, 2 times a1 plus n minus 1 times d. So we're going to evaluate S sub 12 for the arithmetic sequence. So we know a1 is negative 9. And d is a2 minus a1. So negative 5 minus negative 9 is 4. We can double check. We can also say a5, which is 7, minus a4, which is 3, and we still get 4. So we know d is 4. So here S sub 12 is equal to, and since we don't know what a sub 12 is, we're going to use the second formula, which was n over 2, so it's 12 over 2, parentheses, 2 times a1, well here a1 is negative 9, parentheses, plus n minus 1, so here our n is 12, so 12 minus 1, close parentheses, times d, and d was 4, close the parentheses, and close the bracket, and cleaning this up, we have S sub 12 equals 6, bracket, 2 times negative 9 is negative 18, plus 12 minus 1 is 11 times 4 is 44. Negative 18 plus 44 gives me 26, and 6 times 26 is 156. Once again, I used the second formula on the previous page for this problem because I did not know what a sub 12 was. So the first formula didn't apply. Now I could have found a sub 12 and applied the first formula as well. But this one would be faster. Find the sum of the first 95 terms of the arithmetic sequence. So we're using the same formula again. So we have S sub 95 equals 95 over 2, parentheses, 2 times a1, which a1 is negative 10, close parentheses, plus parentheses 95 minus 1, close parentheses, we need to find d. D is equal to, we can say a3 minus a2, which we get 3, or we could have said a4 minus a3, which is minus 4, or negative 4. And negative 1 minus a negative 4 is positive 3, so we know d is 3. So here we have S of 95 equals, I'll leave 95 over 2 as a fraction. Bracket 2 times negative 10 is negative 20. Plus 95 minus 1 is 94. And 94 times 3 gives me 282. And negative 20 plus 282 is 262. So we have the sum of the first 95 terms of an arithmetic sequence is 95 over 2 times 262. So we have 95 divided by 2 times 262 gives me 12,445. Example 6 says find the sum of each series. So yes, for this one, my low bound is 1 and my upper limit is 10. So I can plug in 1, 2, 3, all the way to 10 and then add them up. But the quick way is if I apply the sum formula, which says S sub n equals n divided by 2, parentheses, the first term plus the last term. So here we have S sub 10 because we're adding the first 10 for the arithmetic sequence equals 10 divided by 2, parentheses, A1 plus A sub 10. So we need to find what A1 is first. So A1 is equal to plugging in 1. For I, we have 4 times 1 plus 8. So A1 is 12. And A10 is equal to 4 times 10 plus 8 is equal to 48. And applying this, we have S sub 10. 10 divided by 2 is 5. Parentheses, A1 is 12 plus A10 is 48. 12 plus 48 is equal to 60, and 5 times 60 is 300.